Okay, the question we're investigating here is what's going on inside of a battery, right? We talk about circuits and all these diagrams of current flowing, but what's happening in a battery to actually produce voltage and provide current, right? So, in order to do this little activity, you're going to need your own little bits of supplies here. You're going to want some sort of metal. All right, in my picture here, I've got a penny and a nail, but the main idea is that you need two different kinds of metals. You're going to want a multimeter if possible. You need some way to see if you're producing voltage and current. We'll look at how to set that up here in a few minutes. And then the last thing here, you're going to want some kind of item to put these two metals in. Now, we'll talk more details about what's going on there, but for right now, it would be best if you can find an orange or a lemon. If you can't find an orange or a lemon, even a piece of potato or an apple should be okay to work, and we'll look at some other options here in a few minutes of what else can work. So let's look at what we do with these things. All right, first thing on the list is what do we do with this electrical tester, this multimeter? So hopefully you're able to borrow, steal, snag one of these to use. The first thing is to make sure that your cords are correctly connected at the bottom. The black one should be connected into one that's marked COM for just common. That black one goes there. And then your red one should be in the port that's marked with a V for voltage. You don't need to go over here to this one. Of course, yours is going to look different, but it should be the one that's marked with a V for voltage. Then the next thing is just turning your dial to the correct setting. In a battery, you've got direct current kind of voltage. So that's on my dial, it says VDC, voltage DC. So we're going to turn over to, I'm going to put mine to the 20, which just means that it'll show voltages up to 20 volts on the little digital screen here. All right, now what do we do with the fruit and the metals? Okay, so what we're going to do is we're going to stick one of the metals in one side of the fruit and the other metal into another spot on the old fruit. I've got an old nasty orange here, makes it super mushy. Anyway, there we go. Now, there it is. That's a battery. Doesn't look like it. It looks ugly. But the idea is these dissimilar metals have some chemical traits, and we're going to bring up a little chart here in a minute. But the idea of different metals having a desire to lose electrons versus gaining electrons. So let's bring our multimeter into the picture now. If I can get that in the shot here. Oh, yes. Okay. Now, if I touch the two probes to the two metals, make sure you can see it all at the same time. Okay, I'm getting negative 0.9, kind of jumps around a little bit. Why the negative? Apparently, what I'm calling negative and positive with my colored probes here is incorrect. So I'm going to switch it around here and touch it again. We'll see what happens. So now positive 0.99, basically positive 1. So 1 volt when I have the black one on the nail and the red one on the penny. The black one is the negative terminal and the red one is positive. So what that's meaning is my nail and my orange is negative. It's producing electrons, and my penny is positive. It's accepting electrons. And so hooking these two up in the manner you see is basically a battery. It's the chemistry of the materials involved here that's producing a current. And the voltage, the push behind this, is really the chemistry of the materials. Now, if we think about what's happening here, you've got an orange that has an acid component to it, and that acid is trying to do chemical things to the two metals here, right? Now, when you give them a connection through the wire, then you're kind of setting them up as a complete system. So now the nail, apparently, according to what we just saw with it being negative, the nail is giving up electrons, and those electrons are trying to go over to the copper penny. The copper penny is desiring electrons due to the chemical reactions happening in those two. So let's look at the little reduction chart here and see why that does what it does. All right, we've got this nifty little chemical reactions chart here. Now, I mentioned earlier that I've got a nail and a penny, and so it's like, how does that fit in on the chart? The penny's easy. The penny is copper, right? So it's this little half reaction here. But then the nail, it's like, well, what's in a nail? The nail that I actually chose is a galvanized nail, and galvanized nails mean that they're covered in zinc to prevent rusting. So here are my two materials involved. Now, it's kind of cool if you look at what's happening here. This chart is telling us, this top one, the copper part right here, is telling us that copper ions like to pick up electrons and become solid copper. And it does this with a positive voltage. That means that is likely to happen. Now, down here we see for zinc picking up electrons and becoming solid zinc, that's a negative voltage. That means it's not likely to happen that direction. It means it's more likely to go the other way, that solid zinc is likely to lose electrons and become zinc ions. Now, think back over here to what we saw in the video of the orange with the stuff in it. The zinc was negative. Why was zinc negative? Well, we're looking at it right here. The zinc likes to lose electrons and become zinc ions. Well, where do those electrons go? The copper. The copper ions like to pick up electrons and become solid copper, right? Now, the last piece of this, why can't you just like do it with the nail and the penny, forget about the orange? You have to have the ions and a solution that will allow this. All right, so when I put the copper penny and the nail into this orange, the acid component of the orange is producing these ions in a solution near the metal, right? So earlier I mentioned using things besides an orange. You should be able to use lemons, apples, potatoes, maybe even some other just liquids, like maybe a little teeny cup of vinegar would work. Anyway, kind of play around with this, look at the chart and look at the different metals that you could maybe try this with. Aluminum, so maybe like tin foil, maybe iron, if you can find just a regular iron nail, or use a nail and you sand off the stuff. There's lots of options here. Last thing to kind of point out here that I think is super awesome, if you look at the voltage on these two, 0.76 and 0.34, you put those together and you have really close to 1 volt. And that's what we saw in our multimeter test here a minute ago. We saw 1 volt of push behind current. Now, if you really wanted to get crazy, you can actually hook this whole thing together with like a little LED bulb, maybe use a couple little fruit batteries connected in series to up your voltage, and you can actually light up a light. It's awesome. So, how does a battery work? There are materials involved where the chemistry inside is such, just like we're looking at here, that one material wants to lose electrons, one material wants to gain it, and when you connect that in a circuit, that's what happens. Thinking about rechargeable batteries, just like you see here in these little equations, the equations have an arrow both directions. That means it can go both ways. It's just there's a tendency for it to go a certain way. So in the right engineered situation, the right kind of battery, if you apply electricity back to the battery, you can force this reaction to happen in reverse, and then you just recharge your battery and it's ready to go for the next time.